Okay, so we're going to look at how to work out a question like this when you're given volumes of different gases and then asked to work out a different volume. This works because if you have a constant temperature and pressure, volumes are sort of directly proportional to moles. So before we start, we need to know that the volume of a gas depends on temperature, pressure, and number of moles, but what the gas is does not affect the volume. Okay, so this means that when you have, say you've got 100 cm cubed of oxygen, that will have the same number of moles as 100 cm cubed of nitrogen or 100 cm cubed of butane. Okay, 100 cm cubed of each of these gases would have the same number of moles if the temperature and pressure are constant. So let's try this question here. It says, when 1 gram of butanene is reacted with 10 grams of oxygen, what volume of oxygen remains at the end? So we can just use the volumes, because they're directly proportional to moles, we can use them as moles. So it's saying 1 mole of that, 1 dm cubed, 1 mole, 10 moles of this. So you can see it's a 1:6 ratio. So what's going to happen is this is the limiting factor. So we'll go down to 0. 6 of this will get used up. So this will be -6. So we'll be left over with 4 moles. Okay. And in this situation, 4 moles, because because it's directly proportional to volume, that would be 4 dm cubed of oxygen left over. Okay, why does it work like this? Because of PV equals nRT. Okay, so if we equate that for moles, moles equals PV over RT, and because the pressure is staying constant, R is staying constant, and T is staying constant, moles is directly proportional to volume. So let's go back to one of the questions. Let's start off with, let's try this one first. So this is a proper exam question. It says 30 cm cubes of xenon are mixed with 20 cm cubed of fluorine. Oh yeah, by the way, noble gases do react sometimes. So particularly xenon, actually. We always say noble gases don't react, but they sort of do. Oops, sorry, count on keyboard. Xenon, 30 cm cubed. So we can just think of that as 30 moles. We've got 30 moles of xenon mixed with 20 moles of fluorine. You can see it's a 1-to-1 ratio. The gases react according to the following equation. Assume temperature and stuff must be constant. What is the final volume of gas after the reaction is complete? Okay, so it's 1-to-1 ratio. We can see xenon is the in excess, fluorine's the limiting factor. So this is going to go, as its limiting factor, it's going to be -20. That's going to be -20. And it's a 1-to-1 ratio, so it's going to be +20. Started off as 0. So we're going to have 10 xenon left, 0 fluorine left, and 20 xenon difluoride. Which means we've got a total of 30 cm cubed left over. Okay, so this question here, so this time we've got 30 cm cubed of nitrogen, 60 of fluorine, so 30 moles, 60 because moles are proportional. Okay, so let's work out which one's the limiting factor. You can see they're in a 1/2 to 3 to over 2. That's a bit of a weird ratio. Let's just times everything by 2, so that becomes 1 to 3 to 2 ratio. That's a lot easier. Okay, so we can just find out which one's the limiting factor. It's looking like fluorine's going to be in excess. So to check that, what I'll do is I'll go 60. So I've got 60 moles of fluorine. And I'll just see how many moles do I need of fluorine to fully react with the nitrogen. So the ratio is 3-to-1. So I'll go 60 divided by 3 times by 1. Okay, and that tells me that I need 20 moles of nitrogen. I need 20 moles of nitrogen. Do I have 20 moles of nitrogen? Yes, I've got 30. So this is going to go down by 20. That used up all of the fluorine. So the fluorine is going to go down by 60. So after the reaction, I'm going to have 10 nitrogen left over, 0 fluorine, and then we can use one of these values, doesn't matter which one, to work out how much of the NF3 is going to be produced. Let's use the nitrogen. So it went down by 20. It's a 1-to-2 ratio, so it's going to go up by 40. We started at 0, so therefore we're going to have 40 left of the NF3 left. Okay, so overall we've got 50 moles of gas.